Now, for ionic bonding, we're going to use these Lewis symbols to show the transfer of electrons. Now, this is not how lithium fluoride is made. It's just mined this way. But just for illustrative purposes, if lithium were to give away its one dot and form a lithium plus, giving away an electron, so electrons as a product, and if fluorine were to gain one electron, maybe it's the same one, and become fluoride now with 8 dots, okay, lithium with no dots, fluorine with 8 dots, okay, then the plus minus can get together, lithium plus and fluorine minus, and form this lithium fluoride, okay? Actually, as it's drawn here, we're adding these up. The electrons cancel, so lithium plus fluorine makes lithium fluoride, cation, anion. All right, so we're actually taking this electron and throwing it over there to the fluorine, using Lewis symbols to express the concept of ionic bonding. Now, things to keep in mind. Main group elements form ions that obey the octet rule, duet rule for the small elements. Ions of opposite charge attract, resulting in an ionic bond. Now, it's not just a molecule, LIF, okay? There are alternating pluses and minuses in all 3 dimensions, but the smallest unit possible, theoretically, would be Li plus 1 and F minus 1. Electrons are lost by the metal, they're gained by the nonmetal, and both in the process obtain the noble gas electron configuration. I now give you a moment to examine the cartoon. So here's another example. Looking at sodium chloride. My eye is very itchy today on this recording. My apologies. Sodium loses an electron forming sodium plus in the same way that lithium did it before. Chlorine gains an electron forming chloride in the same way that fluorine did it on the last one. Now this picture is a great one out of your textbook because it really reinforces stuff from the last chapter. Notice sodium atom is bigger than sodium ion. Chlorine atom is smaller than chloride ion. All right? The number of protons in the nucleus, 11, doesn't change, 17, 17. The number of electrons changes, 11 to 10, loss of an electron, 17 to 18, gain of an electron, okay? From the dots, no dots, 8 dots, and again, no dots in quotes, none that are shown. It lost all the electrons in its level and filled chlorine's level. In the process, sodium is now isoelectronic with neon and has the 8 not shown of neon in its outer level at this point as Na+. Okay? Just some overall features of ionic bonding for you. Just should be reminders from the last chapter, so hopefully all of this makes sense to you. Metals form cations because they have a low ionization energy and a low electron affinity. They don't mind getting rid of electrons, and they don't really want electrons for stability reasons. Nonmetals tend to form anions for exactly the opposite reason, high ionization energy and high electron affinity. Easy to gain, not so easy to lose electrons. Ions are formed by the transfer of electrons. Oppositely charged ions are held together by ridiculously strong electrostatic force, plus minus attraction. And reactions between metals and nonmetals tend to form ionic compounds. Now, I've said it repeatedly, and I'm pretty sure I've showed you this picture before. Again, great picture out of the textbook. Sodium element, bigger than the sodium cation. Chlorine, the element, smaller than chloride, the anion. And we have an alternating plus-minus arrangement of those cations and anions. Now, we don't know which chloride goes with this sodium cation. Is it this one? Is it this one? Is it this one? Is it this one? Is it one behind that we can't see? Is it one out here not shown? We don't know. But what we do know is that there's one sodium cation for every chloride anion in this extended 3-dimensional array. We don't talk about small numbers of these things. A theoretical chemist, a friend of mine at the Cooper Union, Robert Topper, came and gave a talk here at QCC a while back. He does theoretical studies of what would happen if you only had 10 sodium and 10 chloride anions. And the answer is weird things happen when you only have a few of them. And then he waits around sometimes 15, 20 years before somebody in the lab can replicate his theoretical results. And so far, he's got a pretty good track record for what he predicts being true. But we're talking about thousands and thousands and millions and billions and moles of cations and anions coming together. Okay, we're not just talking about a few of them. But in either case, there's one sodium cation for every chloride anion. So here's a question for you. I don't know how you'll be able to do this in the structure, but in the answer palette, but I'll figure out some way for you to do it. How would you draw Lewis symbols to represent the formation of aluminum oxide? Do it on paper first. Look back at the sodium chloride and the lithium fluoride one and see what kind of symbols you're going to require to have aluminum oxide in the end. And I'll give you a second here to figure that out and enter your answer. Okay. It takes 2 aluminums and 3 oxygens, although I already gave you that in the question, the formula of the compound. Now, let me just point out for a second that if we had, where's my pen? Okay, here we go. If we took one of these electrons and gave it to an oxygen, and then took another one of these electrons and gave it to an oxygen, that would be it. We would be done with this oxygen. It would have 8. So we need another oxygen, right, with 6 dots. 1, 2, 3, 4, 5, 6. So we can get rid of that third electron for that aluminum and put it there. Well, now this oxygen only has 7. That's not stable. So we need another aluminum with 3 dots. That's where the second one is coming from, okay? So we'll get rid of this electron and give it to that oxygen. Well, now it's done. But aluminum still has 2 dots left, and that's not stable. So we need another oxygen with 1, 2, 3, 4, 5, 6. So we'll get rid of this dot, give it to the oxygen. Get rid of this dot, give it to the oxygen. Now, with 2 aluminums and having no dots, there they are. And 3 oxygens having 8 dots, there they are. Aluminum 3+, isoelectronic with neon, stable, no dots. 3 oxygens with 8 dots, isoelectronic with neon, stable. So Al2O3 is the correct formula of this ionic compound.